In the last classes in power system protection subject, we discussed about so many relays, microprocessor relays and static relays and electromechanical relays. The various advantages and disadvantages we studied previously. Now we go for chapter 2, that is application of these relays. The application of differential relays and static relays, microprocessor based relays, all these relays. First we studied basics. After that we go for application oriented. Suppose differential relay is one which measures the difference between two currents. After that it will operate. The differential relay can be used to protect which application? For what application the differential relay we are using, impedance relay we are using. The remaining chapters and all, application of power system protection relays. Relays where we are applying, that is the unit 2. Protection of generators and transformers. Let us go for protection of generators and transformers. Generators are the very important. Electrical power is generated in power plants. Those are the alternators. The protection of generators or alternators, how we are protecting, those will be studied in this chapter. In modern power system consists of several elements like alternators, transformers, station, bus bars, transmission lines and other equipment. The modern power system consists of, if you go for any power plant, there must be a generator and alternators. The generator may be alternator, transformer, substations, bus bars and transmission lines and substations. We are using step up the substation. Okay, in generating station, generator will be there and the step up voltage transformer, the generating station substation will be there in the transformer. The second chapter is unit 2, protection of generators and transformers. If you go for power plant, the generators are precious because a very limited number of units are there, around 4 or 5 units. If you go for RPPP, thermal power plant in Muddanur, near Kadapa, there are 4 generators, that is alternators. If any one of the fail occur, if any fault occur one generator, they will alter the load to another generator and they will run the another generator. But protection is required. It is a very huge and costly equipment, generator. If total winding gets damaged in case of generators, if there is no protection, what is the use? The equipment will damage. It is a sudden damage to the lot of damage to the alternator if we are not protected. Hence it is precious equipments. Variety, there are number of, it is desirable and necessary to protect each and element from variety fault conditions. Each and every element, that is power system antene generation, transmission, distribution. ఈ జనరేషన్ ఎలా ప్రొటెక్ట్ చేస్తారు జనరేటింగ్ సిస్టమ్స్, అలాగే ట్రాన్స్మిషన్ ఎలా ప్రొటెక్ట్ చేస్తారు యూనిట్ 3, దట్ ఈస్ ఫీడర్స్ అండ్ ట్రాన్స్మిషన్ లైన్స్. యూనిట్ 4 వచ్చి సర్క్యూట్ బ్రేకర్స్ అండ్ ప్రొటెక్షన్ అగైనెస్ట్ ఓవర్ వోల్టేజ్ ఈస్ యూనిట్ 5 అకార్డింగ్ టు JNTU syllabus. Let us go for syllabus. After that we will go for protection of alternators and transformers. The syllabus regarding power system protection, how the protection of generators will be, unit 1 already we studied, that is unit 1 end with microprocessor based relays. Whatever be the relay they asked, if you know 2, the overcurrent relay and impedance relay, you can answer. Coming to unit 2, protection of generators and transformers. The protection of generators and transformers is the unit 2. Protection of generators against stator faults, rotor faults, abnormal conditions, restricted earth fault and interturn fault protection and numerical problems. Similarly, protection of transformer, how the transformer is protected, that is the syllabus regarding unit 2. The first protection generators, after that transformers. Protection of generators and transformers both are same, but in point of view protection we can go for generators and transformers. Generators ni differential protection యూజ్ చేస్తారు, అలాగే ట్రాన్స్ఫార్మర్స్ కూడా differential protection scheme యూజ్ చేసి we can protect. Let us go for in depth. The generator protection, it is unit 5 previously for a switchgear and protection subject. For diploma and BTech it is unit 5 previous, according to previous syllabus. Okay, that's why it is unit 5. Protection of generators against stator faults, rotor faults, all this, that is the syllabus regarding previously. Already we discussed the syllabus. Generator protection, there is a lot of difference between application and relays, basic relays. The most serious fault on alternator or generator, the most serious fault will be in case of generator. As you know that generator is an alternator in power plant. The most serious fault on alternator which requires immediate attention. Suppose in case of alternator, what are the parts if you have on alternator? Already you studied in missions 3 synchronous generator. The synchronous generator is a AC generator. It has stator and rotor. Stator and rotor both will be there on a synchronous generator or generator alternator. The most serious faults on alternator which requires immediate attention. Immediately attention is required. The stator winding faults. If the stator winding gets damaged, the EMF will not be generated. Imbalance will appear. It will damage entirely the alternator. It will damage the entire alternator if any stator fault occur. The major faults on stator is short circuit fault, and rotor. The rotor consists of generator lo rotor ఏ విధంగా ఉంటుంది? The rotor having salient pole, cylindrical structure. The rotor projected pole type rotor. These are the projected pole type rotor, salient pole type, smooth cylindrical type. The rotor. That means field winding will be there on rotor. Based on construction, the stator faults and rotor faults may appear. The stator is a stationary part. 3-phase distributed armature winding will be there in stator. Whereas coming to rotor, there are two types of rotors, that is salient pole and cylindrical. You already studied in previous classes in missions 3 synchronous missions. The stator and rotor both. The rotor also suffer from some faults, that is rotor faults, and stator also suffers from some faults, stator faults. If you know the construction, then what are the faults if you identify? That is very simple. That means previous semester subjects also important to understand generator protection. అంటే జనరేటర్లో ఉండే పార్ట్స్ని బట్టి వాటి ప్రొటెక్షన్ మీద డిపెండ్ అయి ఉంటుంది. స్టేటర్ ఉంటుంది, స్టేటర్ ఫాల్స్, స్టేటర్లో వైండింగ్ ఉంటుంది, రోటర్లో ఫీల్డ్ వైండింగ్ ఉంటుంది, అలాగే ఎగ్జైటేషన్ ఉంటుంది. రోటర్ ఫాల్స్ ఆర్ failure of excitation. Stator faults are interturn faults, failure of over current, over voltage, over speed. Let us so many types of faults occur in generator and stator and rotor, different faults, stator faults and rotor faults. Let us go for that in PDF format, the notes what we written. What are the faults in alternator? As I told you, there are stator faults and rotor faults. Stator faults. The following are the various types of faults occur on alternator as the parts are there. Stator faults. The faults occur mainly due to failure of insulation. Stator lo emuntundi, what the parts are? Stator winding and insulation. If the winding insulation failure occurs, these short circuit faults occur, that is phase to phase fault between RYB phases. The phase to ground fault occurs, and interturn faults occur between the same coil. What are the faults occur? Interturn fault. These are the two types of faults occur: phase to ground, interturn faults. In case of transmission line, also line to line fault, line to ground fault, like that. In case of synchronous generator or stator faults, phase to ground and interturn faults. These are the various faults occur in stator. The stator winding faults are most dangerous because it damages the expensive machinery it is. If the stator fault continues, the danger of this fault is may lead to damage the laminations. In the sense, stator is made with a number of laminations to reduce eddy current losses. Due to that, generated point of fault and hence need to partially rebuild those core, very costly and time consuming. స్టేటర్లో వచ్చిన ఫాల్ట్ మనం ఫాస్ట్ ఐడెంటిఫై చేయకపోతే ఏమవుతుందంటే స్టేటర్ కోర్ డ్యామేజ్ అవుతుంది, లామినేషన్స్ డ్యామేజ్ అవుతాయి. దాన్ని మళ్ళీ తీసి వెరీ హ్యూజ్ జనరేటర్, వెరీ లార్జ్ జనరేటర్ని మనం లామినేషన్స్ రిమూవ్ చేసి మళ్ళీ ఇన్సులేషన్ ప్రొవైడ్ చేయడం, ఇట్ ఈస్ వెరీ డిఫికల్ట్ అండ్ కాస్ట్లీ, టైం కన్జ్యూమింగ్. ఒక జనరేటర్ని ఫాల్ట్ వచ్చినప్పుడు ఏ వైండింగ్ ఫాల్ట్ వచ్చింది అంటే ఫాల్ట్ రాకముందే మనం దాన్ని ఐడెంటిఫై చేయాలి ప్లస్ డిస్కనెక్ట్ చేయాలి ఆల్టర్నేటర్ని. ఒకవేళ ఫాల్ట్ అలా కంటిన్యూ అయిందనుకోండి ఏమవుతుంది, పార్షియలీ రీఇన్సులేషన్ చేయడం కూడా కష్టమే. బిల్డింగ్ ద కోర్ అగైన్ వెరీ కాస్ట్లీ అండ్ టైమ్ కన్జ్యూమింగ్. దానికన్నా కొత్త జనరేటర్ కొనుక్కోవచ్చు. వీ కెన్ పర్చేస్ ఎ న్యూ జనరేటర్ ఇఫ్ ద స్టేటర్ కోర్ డ్యామేజ్. ఇఫ్ యూ గో ఫర్ సమ్ షాప్స్, if the stator gets damaged, simply the electrician will say that instead of repairing that, go for purchasing a new motor. Winding damage aithe electrician will change. If the winding gets damaged, the electrician will change the winding. If the stator core or stator laminations gets damaged, it's very difficult to replace. Hence he suggests a new machine, purchase a new machine or new fan. In this face-to-face and face-to-ground fault, face-to-face and interturn faults are less common compared to face-to-ground fault. ఇన్సులేషన్ డ్యామేజ్ అయితే ఇంకో ఫేజ్ టచ్ అయ్యే ఛాన్స్ తక్కువ, గ్రౌండే టచ్ అవుతుంది ఖచ్చితంగా స్టేటర్లో. ఇంటర్టర్న్ ఫాల్ట్స్ అండ్ పేస్ ఫాల్ట్స్ ఆర్ వెరీ లెస్ కామన్ యాజ్ కంపేర్డ్ టు పేస్ గ్రౌండ్ ఫాల్ట్స్. For protection of alternators against stator faults, differential method we are using. We know that differential relays, merge price system also it is also known as. It is employed and it has a greater sensitivity and reliability also. What is differential relay? You know that what is differential relay. Differential scheme of protection we are employing by providing the current transformers on both sides of alternator. Now coming to rotor faults. Rotor లో ఏముంటుంది, ఫీల్డ్ వైండింగ్ అనేది ఉంటుంది రోటర్లో. టు ప్రొడ్యూస్ మ్యాగ్నెటిక్ ఫ్లక్స్ వీఆర్ హ్యావింగ్ ఫీల్డ్ వైండింగ్. ద ఫాల్స్ అక్కర్ డ్యూ టు మెకానికల్ వైబ్రేషన్. రోటర్ ఆల్రెడీ ఇట్ ఈస్ ఇన్ మెకానికల్, కంటిన్యూస్లీ ఇట్ విల్ రొటేట్ అండ్ మెకానికల్ అండ్ థర్మల్ స్ట్రెసెస్ కెన్ కాజ్ ద ఫెయిల్యూర్ ఆఫ్ ఇన్సులేషన్, ఫెయిల్యూర్ ఆఫ్ ఫీల్డ్ వైండింగ్. డ్యూ టు రొటేషన్ ద ఫీల్డ్ వైండింగ్ maybe gets damaged. These faults are ground faults or short circuit faults between the turns of the field winding. The rotor faults are. In alternator, the field system is not grounded. The field system is not grounded. Normally, it is continuously rotating. Hence, it is not possible to connect ground. Therefore, simple line to ground fault does not exist in rotor fault. Some abnormal conditions are there. Stator faults, after that rotor faults, some abnormal conditions in alternator. Abnormal conditions, not normal, it is abnormal. These conditions are unbalanced loading. In 3 different phases are there. 3 different phases having different currents is known as unbalanced loading. Whenever stator fault occur, one phase gets damaged, remaining 2 phases will be balance the current. That is unbalanced loading is the one of the abnormal condition. And another one is overloading. Overloading means loading the generator more than that. Overloading, that causes over current, and running the generator more speed is over speed. This is also abnormality in the alternator. Over voltage, failure of prime mover, loss of excitation. These are the abnormalities in alternator. First we have to study stator faults. The stator faults, what are the stator faults? Face to face, face to ground and interturn faults. After that, rotor faults, failure of prime mover, failure of field winding, interturn faults between field winding, there is no ground fault. Unbalanced loading and abnormality conditions. Abnormality loading, unbalanced loading results circulation of negative sequence currents in the stator. Unbalanced loading that gives rise to rotating magnetic field. The unbalanced loading can cause negative sequence currents in the stator winding, which gives rise to rotating magnetic field. Rotating magnetic field will be increases. Rotating magnetic field, the field rotates and double the synchronous speed with respect to the rotor, and voltage induced is double. Voltage will be doubled. That is very important. Unbalanced loading causes frequency will double, voltage will be double, and rotor conductors frequency also will be double. And voltage also will be double because of rotating magnetic field which is produced by unbalanced loading, circulation of negative sequence currents. The next one is loss of excitation. The loss of excitation in the sense giving the voltage for field winding or connecting DC supply for field winding. Field winding is excited by DC source in power system, power generation. The loss of excitation of a generator may result loss of synchronism and therefore it behaves as a induction generators. ఎప్పుడైతే మనం ఎగ్జైటేషన్ లాస్ అవుతుందో అది జనరేటర్లాగా యాక్ట్ అవుతుంది, సింక్రోనస్ జనరేటర్ ఇండక్షన్ జనరేటర్లాగా యాక్ట్ అవుతుంది అండ్ డ్రాస్ ఎగ్జైటింగ్ కరెంట్ ఫ్రమ్ ద సోర్స్ ఫ్రమ్ ద సిస్టమ్. దిస్ లీడ్స్ టు ఓవర్ హీటింగ్ ఆఫ్ స్టేటర్ వైండింగ్. దిస్ లీడ్స్ టు ఓవర్ హీటింగ్ అవుతుంది. లాస్ ఆఫ్ ఎగ్జైటేషన్ వీఆర్ గివింగ్ ఫర్ rotor. This leads to overheating of stator winding and rotor body. The one more thing is loss of excitation is causes synchronism loss avutundi plus induction generator laga act avutundi. It is very important objective question. When loss of excitation happens in a synchronous generator, the synchronous generator or alternator acts as induction generator. It is very important. Induction generator. Coming to stator protection. Stator protection, that means protection of alternator against stator faults. What are stator faults? You know, phase to phase, phase to ground, and inter-turn faults between the same coil, between the same turn. If any fault occur, how to protect this? Stator faults are the most common system used for the protection of stator winding faults employs circulating current principle. Circulating current principle we are employing to find that is differential scheme of protection. Differential relays we are using. In this scheme of protection, current at two ends of the protected alternator to be compared. The alternator at the two ends. This is the alternator, this is generating the power and the current transformer is provided. Between this we are providing current transformers. The system to be protected is connected between current transformers. Suppose if it is an alternator, assume that single phase, single line diagram. Between two sides we are connecting current transformers and those are connected to pilot cables and a relay coil will be provided here. This scheme is differential relay scheme. Differential relay scheme mostly used for protection of alternators, stator protection. This is the diagram representing differential protection or merge price protection of generator from stator faults. The alternator three-phase winding we are connected here between two current transformers. This is the alternator, the equipment to be protected between two current transformers, CT1 and CT2, three-phase current transformers. Here earthing resistance we are connecting and these are connected through pilot cables. The two ends of current transformers are connected in star as well as delta also we can connect. Suppose if it is a alternator is in star connection. It is a star connection, we are connecting CTs or in delta. Under normal conditions, when there is no fault in alternator, these currents are equal. These currents are equal but may become unequal whenever fault occur. Whenever fault occur, an unequal current will flow, therefore a current will enter to the relay coil that will energize or trip the circuit breaker. The difference of currents under fault conditions is arranged to the pass to the operating coil of the relay. Operating a coil of the relay, it will connected between current transformers. The relay then closes its contact to isolate protection section of the system. This form of protection is also known as merge price circulating current scheme. Merge price circulating current scheme or differential protection or circulating current protection, both are same. Previously what we shown the diagram, that is the differential scheme of protection. The schematic arrangement will be shown previously. A three-phase alternator is connected at two identical current transformers. Pairs of CTs 1, CT2 are placed either side, both sides, for each phase of stator winding. Between stator winding we are placing current transformers. You can see this diagram. From this diagram what we can predict, the alternator is connected between CT1 and CT2. By using pilot cables we are connected. RYB is the generated voltage it is earthed through a high resistance, that is low resistance has to be provided for earth. Actually it is a star connection alternator. The relay coils are connected between current transformers 1 and 2, R1, R2, R3 are the 3 relay coils, and these are connected to trip circuit. These are connected to trip circuit. This dotted line represents the relay is inoperative condition. When plunger moves upwards, it will close. Whenever fault occur in alternator due to this fault, between phase to phase fault or phase to ground fault, a current will flow through these relay coils. Under normal conditions, there is no current, zero current will flow in the relay coils, because whatever be the current here, suppose 100 amps, 1000 amps is flowing, the 1000 amps will go to again, and after this, like this 1000 amps will flow. Whenever fault occur, abnormality condition, unbalanced loading will happen. At that position, the relay R1, R2, R3, anyone closes its contacts. Whenever it closes its contacts, already DC supply will be connected for this. The operation of relay, you know. In the unit 1, the relay operation, you know. Whenever plunger move upwards, the NO terminals will be closed. Normally open terminals will be closed. It will connect it to trip circuit, the circuit breaker will open. That is the principle of stator protection of alternator. Okay, then operation, how the differential scheme or merge price scheme, how it works. Already I told you, the relays are connected in shunt, in form of shunt, for each circulating current path, circulating path. Differential protection we are employed. Under normal healthy conditions, the current at both ends are equal, and hence the current in the secondaries of two CTs connected in a phase also equal. Therefore, there is a balanced circulating current in pilot wires, and no current flows through operating coils of the relay coils lo no current epudu under healthy conditions. Now when a phase to phase fault occur, the differential current will flow through the relay coil and operates the relay to trip the circuit breaker. There are some limitations are there. For differential protection, there are some limitations. What are the limitations that causes modified differential protection? Due to some limitations, we are changing the differential protection scheme, that is modified differential protection scheme. What are the limitations? The neutral earthing resistance is used to generator to limit destructive effect of the earth fault current. In such situation, it is impossible to protect whole stator winding of star connected alternator during earth fault. If any earth fault occur, already we connected earthing resistance to limit the destructive effect. అంటే ఫాల్ట్ వచ్చినప్పుడు, ఎర్త్ ఫాల్ట్ వచ్చినప్పుడు హై కరెంట్ పోయేసి మొత్తం డ్యామేజ్ అయిపోకుండా వైండింగ్ వీ ప్రొవైడెడ్ వన్ రెసిస్టెన్స్, ఎర్త్ రెసిస్టెన్స్. ఆ ఎర్త్ రెసిస్టెన్స్ వల్ల మొత్తం వైండింగ్ కనెక్ట్ చేయలేం, ప్రొటెక్ట్ చేయలేం. అంటే సమ్ పర్సంటేజ్ ఆఫ్ వైండింగ్ ఓన్లీ. దట్స్ వై ఇట్ ఈస్ నోన్ యాజ్ పర్సంటేజ్ మెర్జ్ ప్రైస్ ప్రొటెక్షన్. ఇట్ ఈస్ ఆల్సో, దట్ ఈస్ వన్ ఆఫ్ ద డ్రాబ్యాక్. When a earth fault occur near neutral point, it is a neutral point we connected. When earth fault occur near neutral point, a resistance is connected. There may be insufficient voltage across the short circuit portion due to drive the necessary current to operate the relay. ఎర్త్లో ఫాల్ట్ వచ్చింది అనుకోండి, అంటే జీరో కరెంట్ ఫ్లో అవుతూ ఉంటుంది ఎర్త్ ఫాల్ట్ వచ్చినా కూడా ఆల్టర్నేటర్లో. అది డ్రాబ్యాక్. దీనివల్ల ఏం చేస్తాం మనం? డిఫరెన్షియల్ ప్రొటెక్షన్, modified differential protection for alternators, we go for that. The modified differential protection scheme we are employing by connecting a balancing resistors in all three phases, and one inductor, one resistor. We are connecting balance protection. That means if the neutral point of star connected alternator earthed through high resistance, protection scheme that will be modified differential protection we are using will not provide. If any earth fault occur here in alternator, it will not protect. To modify this modified differential protection we are using, it is to be caused that high earthing resistance will limit the earth fault current to a low value. The modified differential protection consists of what are the parts? It connecting two relays for phase-to-phase fault protection. Two relays we are connecting for phase-to-phase fault protection, and third for earth fault protection only. The two phase elements PC and PA, the two phase elements PC and PA and balancing resistor BR are connected in star, and the earth relay ER we are connecting between this star point of fourth wire of circulating current pilot circuit. It is the fourth wire. Yes, a earth fault relay we are connecting to protect from earth faults also. What is the operation of this under normal operating condition, under healthy conditions? Current at the two ends of each stator winding will be equal. Currents at the two ends of the stator winding will be equal. Under the two ends, here and here, the currents will be equal. Therefore, there is a balanced circulating current in the phase pilot wires. These are the pilot wires. Phase pilot wires. And no current flows through the operating coils of the relay. No current will flows through the operating coils of the relay. And these are the phase relays, and it is a balancing resistor and earth fault relay. Consequently, the relay remains inoperative. Inoperative in the sense circuit breaker will not trip. In earth fault occurs on any one of the phase. Assume that on any one of the phase, if any earth fault occur, any one of the phase, the out of balance secondary current, imbalance will appear. Out of balance secondary current CTs, that phase will flow through the earth relay ER. It will flow through pilots S1 and S2. Through pilot cables S1 and S2 it will flow if any earth fault occurs. Whenever earth fault occurs, earth fault relay only operate. If you go for substations, in generating station substation, earth fault relay they will mention directly. Earth fault relay, the purpose of earth fault relay is protect the alternator from different earth faults. This will cause the operation of earth fault relay only. If a fault occur between two phases, any two phases, the out of balance current will circulate round the two transformers secondaries. These are the CT secondaries are connected like this. Out of balance current will circulate around the two transformers secondaries via two coils PA and PC and BR. Balancing resistor, braking resistor or balancing resistor, earth relay it is ER is, and PA-PC are the phase fault relays. Under fault condition of earth fault, phase-to-phase fault, without passing through the earth, the relay ER, therefore only phase-to-phase fault protection will operate. PC and PA only operate. Under earth fault, this relay will operate because it is a neutral wire, it is a common wire that is connected to ER only. This is the modified differential protection scheme for alternators. Modified differential protection scheme ఏముంటుందంటే మెయిన్గా ఇక్కడ మనం 3 relay coils బదులు 2 relay coils are used for phase to phase fault. 1 relay coil, earth fault relay coil we are using. That is a modified differential protection, merge price protection. Next we go for balanced earth fault protection. How to protect rotor faults and different things. What are the stator faults? Up to now we are discussing. After that we go for remaining topics.